Okay, welcome to Algebra 2, Unit 8, Section 4, the law of sines and the law of cosines. Let's begin. Alright, so the law of sines can be used to find lengths and angle measures for any type of triangle. So we can now use sine to work with triangles beyond right triangles. Okay, you can use the law of sines to solve a triangle if you know the measures of two angles and any side length. So you need one side and at least two angles. Okay, so if triangle ABC has lengths A, B, and C representing the lengths of the sides opposite the angles with measures A, B, and C, then the sine of A over A is the sine of B over B, which is the sine of C over C. You'll notice with the color coding that you can see here that these angles always, it's the side opposite them. So let's do some example problems and this will make more sense. Okay, so in this triangle we have a 97-degree angle that matches up with a side length of 16 and then a 21-degree angle that matches up with x. So we're going to set up our law of sines. So in this case, the sine of 97 over 16 is equal to the sine of 21 over x. So we're going to cross multiply and end up with x times the sine of 97 equals 16 times the sine of 21. We're going to divide each side by the sine of 97 here, and we get x is equal to 16 sine of 21 over the sine of 97. Alright, so we'll take my calculator here and we'll plug it directly in. 16 sine of 21 divided by sine of 97, and we can hit enter and we get 5.77. so this x would be approximately 5.8. Alright, so now in this problem, again, you always have to work with the angles that are opposite. Well, we have nothing here. We don't have a value. Alright, so we're going to go and use what we know about triangles, which is that all their angles have to add up to 180 degrees. So 45 plus 73 is equal to 118. So 180 minus 118, that comes out to 62. So this angle here is 62 degrees. Alright, so now we can match up. The sine of 62 over 10 is equal to the sine of 45 over x. So we're going to cross multiply again. X times the sine of 62 equals 10 times the sine of 45 divide each side by sine of 62, and I get x is equal to 10 over the sine of 45 is equal to the sine of 62. So now we take out our calculator again, and we're going to plug in. So 10 sine 45 divided by sine 62. And I get 8.0084, right? So we would say that x is equal to 8.0, showing we rounded to the nearest tenth. Okay, so the law of cosines can be used to find side lengths and angle measures for triangles where the law of sines cannot be used. And that's going to be because you need at least two angles to use the law of sines. In this case, we only have one angle, or actually no angles, and we can use the law of cosines to solve. Now this is a little more involved. Okay, so let's take a look at this. What this says is that we know, so these are we know this side here, right? And let's say we know this angle measurement. Okay, so we know this angle here. Okay, so basically, or I don't know this side. This is unknown. I know these two because it's got to be side, angle, in between side. So I can plug these values, what I know here, what I know here, and what I know here, and we can solve for this side here. Okay. If we don't know any sides, we don't know any angles, excuse me, we can just use the sides and plug in and then solve for that angle measurement using the inverse function in our trig functions on our calculator. So it's probably easier to understand by doing it. So let's go ahead. Okay. So in this case, I know this angle like we talked about. So this is what we're going to solve for x. So x squared is equal to 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 28. So we can plug this whole thing right here into a calculator. So let's do that. So I've got 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 28. And I can hit enter. So I've got x squared equal to approximately x squared equal to this value here. So I'm going to take the square root of that value, square root of this value, and hit enter. And I get 5.2. Okay. So that one's not too bad. Okay, we can just plug everything in and let the calculator do the work. Okay, on this one, I don't know this angle, but I know the value across from it, right? So 8 squared is equal to 3 squared plus 6 squared minus 2 times 3 times 6 times the cosine of x. Alright, so let's clean this up. I got 64 equals 9 plus 36 minus 2 times 3 is 6 times 6 minus 36 cosine of x. So 64 equals 45 minus 36 cosine of x. So 64 minus 45 is 19 equals negative 36 cosine of x. Divide each side by negative 36. I got negative 19 36 is equal to the cosine of x. So we can now get rid of the cosine by bringing it over here. Cosine negative 1, negative 19 36 will equal x. So now we can take our calculator. So we go ahead and bring that up. Let's clear all this other stuff out. And we're going to hit second cosine negative 1. Alright. And I'm going to put negative 19 divided by 36 in the parentheses. And hit enter. And I got 121.855. So this would be, x would be approximately 121.9. Alright, so now in this one we're going to solve this triangle. So we're going to have to do two law of cosines, and then we can revert back to what we know about adding up angles. Right? So we know all the sides of the triangle. We don't know the angles. So we'll start with angle A. Right? We're going to go with angle A to start. That's the one I'm going to do first. So 15 squared is equal to 12 squared plus 13 squared minus 2 times 12 times 13 times the cosine of A. So I can take my calculator, and 15 squared is 225 is equal to 144 plus 169, and I'm going to multiply that through with my calculator. So 2 times 12 times 13, I get 312. So minus 312 times the cosine of A. So 144 plus 169 is 313. So 225 equals 313 minus 312 cosine of A. Right? Okay. So 225 minus 313, I got negative 88. So this is negative 88 is equal to negative 312 times the cosine of A. I'm going to divide each side by 312, and I get 88 over 312 is equal to the cosine of A. So now we take the inverse cosine -1 of 88 over 312 is equal to A. So plug that in. So we're going to say second cosine 88 divided by 312 and hit enter, and I get 73.6. So A equals 73.6. Now we'll do B, right? So 12 is across from B, right? You could do C if you wanted, but we're just going to do B. So 12 squared equals 13 squared plus 15 squared minus 2 times 13 times 15 and the cosine of B. Okay? So that's 144 is equal to 169 plus 225. I'm just using my numbers from the prior problem. I'm going to put this in the calculator. 2 times 13 times 15, not 5, 15. That's 390. Cosine B. So 169 plus 225 gives me 394. So 144 equals 394 minus 390 cosine of B. So 144 minus 394 gives me negative 250 equals negative 390 cosine of B. Divide each side by negative 390, I end up with positive 250 over 390 equals the cosine of B. So this is equal to cosine -1 of 250 divided by 390 equals B. So we're going to go ahead and plug that in now. All right? So second cosine 250 divided by 390, I end up with 50.1. So B equals 50.1. So I can take these two angles, add them together, subtract that from 180, and I can find angle C. So let's do that. Right? So I've got 73.6 plus 50.1, and that comes out to 123.7. 180 minus 123.7, and I get 56.3. So angle C is equal to 56.3.
That's all, folks.